referencing the 1980 eruption of Mount St. Helens to illustrate many of the things that we would generally talk about in geology. I looked through, and that seemed to be the best way to really give you a good sense of what's going on. Though, in terms of a volcanic eruption, you're talking about a lot of these processes that normally take extraordinary amounts of time happening very quickly. So take it with a grain of salt. Normally geology just really doesn't happen this fast. We measure things on timescales of hundreds of millions of years. In this case, a lot of the things that you'd normally hear about happened in less than 24 hours. These are human timescales, not normally applied. The first thing that gave anybody any indication that Mount St. Helens had come back from its 120 plus years of being dormant were seismic activity. They were seeing low-level seismic activity and ranging all the way up to 4.5 on the Richter scale. Now, you got to keep in mind when we're talking about the Richter scale, every one is an increase of 10 in magnitude. So, a 4.5 something you're going to feel. 3, you're not likely to ever notice that. So these things can get pretty violent and pretty fast when you're going through that numbering system. 4.5 can do a little bit of damage, though generally, as long as it's clear area, you don't really have to look forward to much. But it's something that'll you'll take notice to. Now, this indicated that there was activity going on with magma beneath the volcano. Of course, with magma beneath you, close to the surface, you're going to start getting heating effects. And they did. Probably the first thing that was noticed eruption-wise was that the mountain was venting steam as it vaporized groundwater and things like that. And from there, things led down, we'll call it downhill, pretty quickly. When the volcano finally did erupt, it erupted something called A'a, which is a Hawaiian word for, it's the really thick, blocky type of lava, where what you're used to looking at maybe when you watch a video of Hawaii, that's pohohoi lava. It's very fluidy. It moves a lot more like water than it does like ice cubes. That's the best description I can give you, I suppose. But, when that finally happened, the volcano actually blew off its north face. It just slid down the mountain, and that was lost to the ages. It is actually still gone. Now, let's keep in mind that Mount St. Helens is a stratovolcano, which is essentially a lightly cemented rubble pile. So it has a higher angle of repose than other types of volcanoes because the material is being cemented by the lava from the volcano and making it able to stand up a little taller. Mount St. Helens ejected quite a bit of material, about 80,000 feet into the air, in fact, and across 11 states. I'm sure that it probably reached a little bit further but in minor and inconsequential detail, so that's not particularly important. Some of the more distressing things from the eruption were the lahars, or mudflows. This is where massive amounts of debris and water get mixed together. It was said to have had the consistency of wet cement. So if you think of about how dense wet cement is, and this is flowing down with in stream beds and whatnot at very high speed, we're talking close to 100 miles an hour in some places, then that's an issue. Part of the water from that was when the mountain erupted, it melted all of the glaciers on its summit, and those provided quite a bit of the fluid material. Although, let's clarify here, saying fluid material, anything can act like a fluid given enough energy. In the area where Mount St. Helens is located, it flattened trees, killed wildlife off, but from a geological perspective, the material, the many feet of material that it laid down in ash and other rubble constitutes new strata. So this is something that we have a layer of material that will be incorporated into the stratigraphic record. This is where you get one layer on top of another layer on top of another layer of stuff, and it's unique to an area. In this case, most of it was, until it gets worked out, volcanic glass. Now the shearing off of the north face of the volcano, you can look at that as a form of physical erosion. That's essentially what it is. Also, with the mud flows, those had an effect on the beds where they were running through, because they provided a lot of energy where there wouldn't normally be quite so much. But they were depositing material as well as taking away material as they moved. Alright, well, thank you for watching. I know this has been brief. I hope it was entertaining for you. If you liked it, check out the button below. Give us a thumbs up. And we hope to see you again soon when we're going to be putting up the presidents. I know elections are over. Please stop. But, you know, let's get out of the politics and into the history. That's the interesting part there.